So in this video I'm going to run through the exam questions that you need to do to prep for quiz 4. There are a few tricky exam questions relating to the halogens and displacement reactions, and rather than going through the questions one by one, I'm just going to do all of those difficult questions together. So the first one is on page 18, we question 11. And before I look at the question itself, I'm just going to remind you what the displacement reactions are. So as I said, we're looking at the halogens. I've got fluorine, chlorine, bromine and iodine, and as you go down the group they're getting less reactive. That means fluorine at the top is your most reactive halogen and iodine at the bottom is your least reactive halogen. I've written out a displacement reaction here. So I've got chlorine by itself reacting with sodium bromide. And in these displacement reactions, if the halogen that's by itself, which is chlorine, is more reactive than the halogen bonded to the metal, which is bromine, then they will swap places. And we can see here, because chlorine is above bromine, chlorine is more reactive than bromine. So chlorine pushes bromine out of the way and it takes bromine's spot next to sodium. And when chlorine is bonded to sodium, instead of calling it chlorine, it now becomes chloride. It becomes sodium chloride. Where does the bromine go? Well, the chlorine was by itself. Now the bromine's by itself. And again, when it's by itself, it ends in INE. And these are called displacement reactions. And you can do them, lots of different variations of them. But in these displacement reactions, you will always see a color change. So at the start of the reaction, if we look on the left-hand side, the colour is always determined by the halogen that's by itself. So here, chlorine is by itself, and chlorine is a green gas, but dissolved in solution, it can look colourless, or kind of a very pale green colour in solution when it's dissolved in water. And then on the other side of the reaction, we've got bromine that's by itself. And bromine is normally a brown liquid, but when you dissolve it in water, it looks orange. So it starts off colourless because chlorine's by itself, but it ends up orange because at the end of the reaction, bromine's by itself. Okay, so there's just an example of displacement reactions. Okay, always the halogen that's more reactive takes the place of the halogen that's less reactive, and you see a colour change. So now let's have a look at the question at hand. So you're told that these are all elements in group 7, and you're told bromine, chlorine and iodine are dissolved in water, so they're aqueous. And then you're told that potassium iodide is added to each of these solutions. So essentially what you've got here, if we just look at the first one, you don't need to be able to write equations for all these, but they're telling you you've got bromine and you're adding it to potassium iodide. And then they tell you that when you do that, when you add bromine to potassium iodide, you see this colour change, and they want you to explain why. But what's exactly happening here? I've got bromine by itself and I've got iodine in the compound bonded to potassium. Is bromine more reactive than iodine? Well, bromine is above iodine, therefore bromine is more reactive than iodine. And what's it going to do? It's going to push iodine out of the way and take its place. So what's going to happen here is potassium is now going to be bonded to bromine, and when I bond it, I call it bromide, and I've got iodine at the end. But rather than just writing that equation, you need to explain why it's happening. So why is it happening? All right, so you're going to write bromine is more reactive than iodine, so it displaces iodine. You could write that as it takes the place of iodine, but it displaces iodine. Bromine is more reactive than iodine, so it displaces iodine, and that's actually effectively all you have to write. You don't need to be able to explain why. So bromine is more reactive than iodine, so it displaces iodine. All we can say here, and we see the colour change. Okay, the next one, you've got chlorine. Chlorine, you're also adding into potassium iodide. Is chlorine more reactive than iodine? Yes. So chlorine will take the place of iodine. And again, you're going to write that. You're going to write chlorine is more reactive than iodine, so it displaces iodine. And again, you're going to see a colour change. And then the last example, you've got iodine. So you're reacting iodine with potassium iodide. Now iodine and iodide, they're the same two halogens. So iodine can't displace itself. You're not going to get any reaction if the halogen by itself is the same as the halogen by its compound. So you're just going to write iodine cannot displace itself, so there is no color change there. So no color change. All right, if we come over here, we've got another reaction, another displacement reaction. So they're saying, give a reason why this reaction occurs. So this is like a simpler version of the question we've just done. They give you the full equation, okay? They're showing you that chlorine and bromine are swapping places, okay? And they want to know why. Why does it happen? Chlorine is more reactive than bromine, so displaces it. So displaces bromine, so takes the place of bromine, okay? The next one down here, they're asking about color changes. So this time they've written you the symbol equation, but again it's sodium iodide and bromine. Bromine is more reactive than iodine, so bromine takes iodine's place and you get iodine left by itself. They're telling you the mixture turns brown. So again, if we wanted to work out the exact color change, we would see here, bromine is the halogen by itself at the start of the reaction, iodine is the halogen by itself at the end of the reaction. Bromine in solution is orange, iodine in solution is brown. And they're just asking you what's the name of the substance causing the brown color. So you can't write I2, you have to write the name, and the name is iodine. Iodine is causing the brown color. Now, they also can ask you in these equations what has been oxidized and what has been reduced. And I'll just remind you of oil rig. Oxidation is loss of electrons, and reduction is gain of electrons. They want to know what is gaining electrons as you move from the left to the right. So I think the easiest thing to do here, apologies if these aren't on the same page, I'm just going to write this one over on the other side of the page. Alright, so if I write that full equation on the other side, so I had 2NaI plus Br2 going to 2NaBr plus I2. I think the easiest thing to do here is to write the ionic equation. Okay, so I'm just going to remind you how to do that. So sodium iodide, metal and a non-metal, is ionic. Bromine is covalent, it's just two non-metals. Sodium bromide, metal, non-metal, is ionic. Iodine, two non-metals bonded together, covalent. If it's ionic, you need to show the ions that are involved. So sodium is in group 1, therefore sodium has a +1 charge. Iodine is in group 7, therefore iodine has a -1 charge. Okay, and there's a big 2 in front of sodium iodide. So when I split up sodium and I split up iodine, I still need to include that 2. So I've got a 2 in front of sodium and a 2 in front of iodine. Okay, so I'm just separating sodium and iodine. I'm showing their charges because they're an ionic compound, so they are made of ions. And I'm putting a 2 in front of sodium and in front of iodine because that 2 was affecting both of them in the original equation. Then I get to bromine. Bromine is covalent. If it's covalent, it's not made of ions, so it doesn't change. On the other side, I've got another ionic compound. Again, sodium is in group 1, so it's got a +1 charge. Bromine's in group 7, a -1 charge. There's a big 2 in front, so I need a 2 there and a 2 there. And then at the end, iodine is covalent. If it's covalent, it doesn't have ions and it doesn't change. Sodium is exactly the same on both sides of the equation. It's not changing. So I can cross it out, and what I'm left with is called my ionic equation. And I think your ionic equation makes it easier to see what is losing electrons and what is gaining electrons. Okay, so if we look at iodine, we can see on the left hand side that it's got a -1 charge. I'm going to write a -1 there under iodine to make it really clear. And if we look at what happens on the right hand side, iodine does not have any charges, so I'm just going to say it's 0. On the left hand side, bromine has no charges, so I say it's 0. And on the right hand side, bromine has a -1 charge, so I'm going to write that underneath. Okay, now we know reduction is gain of electrons, so I need to use these charges to figure out what is gaining electrons. If something gains electrons, it's gaining something negative and it ends up with a negative charge. So what didn't have a negative charge on the left hand side but does have a negative charge on the right hand side, and that is bromine. Okay, it started off with no charge, it gained electrons to end up with a negative charge. So what has been reduced? Bromine has been reduced. It didn't have any electrons on the left-hand side. It's gained electrons to form bromide ions on the right-hand side. So you can write here, bromine has been reduced because it's gained electrons, and that will get you your marks. Okay, there is another example down here, very, very similar, and they're telling you that in this reaction chlorine has been reduced, but they want you to explain using the equation how you know. Okay, so again, they've given me an equation. I would write the ionic equation. I think it makes it a lot clearer. So again, Cl2 is covalent. This one is ionic, covalent. Remember, ionic, metal and non-metal, covalent, just two non-metals. If it's covalent, there are no ions, there are no charges, it stays the same. If it's ionic, you have to show the charges. So, potassium's in group 1 with a +1 charge, and I've got bromine in group 7 with a -1 charge. So I'm just splitting up KBr into potassium ions and bromide ions and showing the charge on both. I do the same with KCl. Potassium's in group 1, +1 charge, chlorine, group 7, -1 charge. So again, I'm splitting them up. And when I get to bromine, bromine is covalent, therefore it does not change. Exact same on each side, so I can cross them out, and this is what I'm left with. And they're asking me specifically to talk about chlorine, and I can see that chlorine starts with no charge on the left-hand side, but ends up with a -1 charge on the right. Now, if it has a minus charge, it means it must have gained electrons. So explain using the equation how you know that chlorine has been reduced. Okay, and I can say chlorine has gained electrons, so has been reduced. Now you can also represent this in an equation, and sometimes and actually in the next question we are going to be asked for it, so I'm going to show you the equation. All right, if I want to write a half equation, then I want an equation that has chlorine and no other element in it. When I'm doing this, I look at the left-hand side of my equation and I write down exactly what chlorine looks like on the left-hand side, which is just Cl2. Then I go to the right-hand side of my equation and I write down exactly what chlorine looks like on the right-hand side, which is 2Cl-. So all of those charges have to stay exactly the same. So I can see it's going from having no charge to having a -1 charge. What's happening? We said in order to get that negative charge, it must be gaining electrons. So I'm going to write plus an electron. But because I've got two chlorines, and they each want to gain an electron, I need to give it 2 electrons in total. And that's a half equation, and that, being able to write that, would get you all of your marks, because you're showing that chlorine is gaining electrons to form the chloride ions on the other side. Now the next question asks you to write a half equation for the formation of bromine from bromide ions. Okay, so again, if you go back here to your equation, if I want to write the half equation for bromine, I look at the left hand side of my equation. What does bromine look like? Right, it looks like 2Br-1. So I write 2Br-1. I look at the right hand side of my equation. What does bromine look like? On the right hand side it's Br2. So I write down Br2. And then I need to show what's happening in terms of electrons to get from this side, from the left to the right. Okay, so on the left hand side, bromine has a negative charge. It's negatively charged because it has already gained electrons. I don't want it to have a negative charge anymore. I want it to be neutral. So if it's negative because it has extra electrons, if you take those electrons away again, you'll also take the charge away. So it's negative because it has extra electrons. Take away the electrons, you take away the charge. Now there are 2 separate bromide ions. They each need to lose an electron. So again, I'm going to need to write it 2. And that's your half equation for bromine that you would need to write here. 2Br minus 2 electrons goes to Br2. There is one more. Okay, so these questions, they do, I know they're a bit tricky, but they do come up a lot. Okay, and they're worth a lot of marks. So the elements in group 7 are known as the halogens. Sodium reacts with bromine. Write a balanced equation for the reaction between sodium and bromine. Okay, so this one's a little bit more straightforward. I've got sodium with bromine. So sodium by itself as an element is Na. It is not diatomic because metals never are. You're reacting with bromine. Bromine is Br, but as an element it is diatomic, so I need a 2. And sodium and bromine are going to combine to form sodium bromide. Okay, now sodium bromide is an ionic compound. For an ionic compound you need to use the charges on the ions to work it out. So sodium's got a +1 charge, bromine's got a -1 charge. Those charges immediately cancel, so the formula is NaBr. Now the temptation here might have been to just stick the Na and the Br2 together, but when you're working out the formula of an ionic compound, you have to use the charges. Okay, when they're elements, there's no charges. You just look at the periodic table. The only thing you need to worry about is it diatomic? But when it's a compound, an ionic compound, you'll use charges. So the way I've got it written at the moment is not balanced. So in order to balance this, I'm going to need to put, I've got 2 bromines on the left, a big 2 here, 2 bromines on the right. That gives me 2 sodiums on the right. To get 2 sodiums on the left, I put a 2 over there. In another experiment, a student adds colourless sodium bromide solution to chlorine water. State what you would see. Okay, so they've got sodium bromide. So they've got sodium bromide, and they're reacting that with chlorine. Don't be put off by the chlorine water. That just means chlorine is dissolved in water. But I said all of these displacement reactions take place in water. So this is the reaction, and they want you to know what you would see. It's a displacement reaction. Chlorine is by itself. It's more reactive than bromine, so it's going to take bromine's place. So it's going to swap places with bromine, and you're going to get sodium chloride, and you're going to get bromine. And they're not asking you for the equation, they're asking you what you are going to see. And we said in these reactions you're going to see a colour change, but you're going to need to be able to say what that colour change is. So you start off, chlorine is by itself, and chlorine, when it's dissolved in water, is going to look colourless. At the end of the reaction you've got bromine by itself, and bromine dissolved in water is orange. So you're going to see a colour change from colourless to orange, because at the start of the reaction chlorine is by itself and chlorine is colourless. At the end bromine is by itself and bromine is orange. And then it gives you, in the next bit, it gives you the ionic equation. So it's the first time it's actually given you the ionic equation. We don't have to write it. It wants to know what's being oxidized in this reaction. So oxidized, we know oil rig. Oxidation is loss of electrons. What is losing electrons? So again, if I just assign my charges here, so bromine has got a minus charge, so I can see that that's -1. Chlorine, there are no charges there, so I write a 0. So if there were charges, it would be shown in the ionic equation. The fact that there's no charges means you can add a 0. Chlorine there is again -1, and bromine is 0. So what's losing electrons? What had a negative charge on the left hand side and doesn't have a negative charge on the right hand side? That would be bromine. Okay, so if I look at bromine, if I write myself a little half equation for bromine, on the left hand side of the equation, 2Br minus. That's what bromine looks like on the left hand side. On the right hand side of the equation, it's Br2. So it has a negative charge on the left hand side. That means it had gained electrons, but on the right hand side, it does not have that negative charge anymore. It must have lost electrons. If it's losing its negative charge, it's losing electrons. There's 2 bromide ions, they'll each lose 1, so it's -2. So explain which species have been oxidized. There's your half equation. Now if you wanted to write this in words, well, I would say don't, because you might make a mistake. If you wrote this in words and said bromine is oxidized, you're wrong, because this cannot be called bromine. This is a bromide ion. And to avoid making that mistake, I would just write the half equation and then say oxidation is loss of electrons. And you're showing what's losing electrons, and then you're explaining that oxidation is loss, therefore that this is being oxidized. But if you wanted to write in words, it's bromide ions. If you call it bromine, you're not going to get that mark. You could, again, avoid words and just say Br minus, or you could even write 2Br minus, they won't penalize you. 2Br minus is oxidized, it's fine. So rather than converting to words, stick with the chemical formula. but if you convert it to words, you need to be careful that you're calling it a bromide ion. I know there are other questions, but I think for the most part the others, if you look at their mark schemes, you'll be able to get the answers. These displacement reactions are a little bit harder, and writing the equations for them, being able to state the colour changes, being able to explain what's oxidized and reduced is going to take time, and it's going to take some practice.